Hello, guys. I'm George Gonzalez, and I'm obsessed with making games. And today we are going to talk about a shader, special shader that I've used for my dragon spell. And I'll show you what I mean, and so that you can see what we're working on with today. So as you can see, the dragon will appear as it's coming out from wherever I decide to spawn it. So I could be looking up, and it'll still create that effect. So regardless of where it's coming from, I can spawn it, and you see that. Okay, so that is what we're working on today. So let's go through the dragon. As you can see in here, the dragon moves through. And the first thing I'm going to tell you is if we want, right now, because of the lighting and the way this works, you can still see parts of it. So it's not completely opaque. If you want to polish that feature, you can. And if you wanted to, like, we can do that in this. At least what we can do is, instead of doing a transparency alpha channel, we can do something that will remove it completely, and that will be an alpha cutoff. And that way you can have a clear line and you'll see nothing rendering. That's another option. And what happens is when we draw, and this is specifically to VR, you can do things your own way. Obviously, if it's a 3D game, it's not VR or mobile, PC, whatever you want to do, that's fine. I just want to show you so that you understand that it's just a point and a position, a rotation. So in this case, we have a spell setup and we have the controller and we have points. Because I'm drawing spells, I have the points. And in this case, we have a triangle. So I know that I'm trying to find the centroid of the triangle so that I can spawn it in the middle. That's all I'm doing. The direction is the way the camera is facing. So I say, hey, this is the spawn point and the camera, so I'm looking that way. So this is linear algebra. You just do the destination minus the start, and that will give you the direction. So A minus B gives you AB direction. And if you want to BA, the other one, you just swap these. So if you wanted to face the camera for some reason, you could do that. The rotation is just a quaternion look at, and that's, again, the direction that you're going in. So just so that we can get a quaternion instead of a vector. Okay, so, and that's our final rotation. Obviously, you notice that we spawn, we do like an offset. That offset I need to modify because it's off. That's for the spawning of the spell. So these are just like small technicalities, nothing to do with the shader. But then in here we have the world position and the forward direction. This is where the object is going to spawn. The dragon is. And so we want to start the setup. And the setup is, I mean, these are all part of the spells and other things. The main thing is that we have the world position and the forward direction. And when we set it up, again, this is networked, right? So how do you set up the material, and then how do you network it? So in here, what we have is we have the setup material cutoff location, regardless of where you're at. It's right. This happens before spawn. And then, so it sets all the values ahead of time. So when we set it up for regardless of you have state authority or not, we're going to set up the cutoff. That's the first thing we do because we want to make sure it's at the right location. So we grab the render materials, and it's just one for now, but it used to be that we had multiple ones. So just in case, this gives you the ability to go through all the renders materials and create and add the materials to a list. So the reason why we do this is because if you just alter the material, it won't, the effect will be the same for every dragon spawn. So let's say I have a dragon spell and someone else has a dragon spell, and you both do the dragon spell. If we're altering the material, we're going to get weird offsets because we're using the same material everywhere in the project. So this allows you to create a new material and assign the values to that material. So we instantiate it, and we go through each of those materials, and we set these values. And these values go into the shader, and that's what we're going to go in. So these are all small technicalities that usually if you have a tutorial online you find on how to modify a material, what happens is that you create a material in a vacuum and you create certain values and you adjust it and you get it working, but then you're like, oh wait, how do I apply it to my game? And so this first part, if you need to rewind, you can rewind, but all of what I just showed you is the setup in a real world scenario for a real game. So I'm using this for my game, and as you saw, it is working, right? Any direction, it works in multiplayer, it works with multiple. Like I could spawn 2 different dragons. I didn't show you that, but I could spawn dragons one after the other, and each dragon will have the cutoff on in separate instances. So it doesn't affect the other dragons, changing these values. Because you'll notice those are some of the gotchas. You'll create a material and you'll just set you'll grab the material by reference, and then you'll change the positions and you'll do a bunch of tweaks. And then you're like, why is my other material changing too? So it's because it's using the same reference, and all the other dragons will be using the same reference. So this allows you to do that, to change it. You don't have to do for each. This is in case you have multiple materials. Again, you might have multiple mesh renders that you want to do this. And so this will give you the ability to do that. All these things are edge cases, things that come up when you're actually implementing things in your game. And that's my focus, is actually doing these things in game so you could see them in a working environment. Not just like in an empty scene with a specific rotation. This works in any rotation, any angle. It just works. So you got the setup. Now we're going to talk about the shader. And if you have questions, leave them below. If you get stuck somewhere making your own shader, I'm happy to help. ChatGPT is a great help going back and forth. As long as you know what you're doing, it usually helps. Sometimes ChatGPT gives you the wrong things, so you have to play around with it. But let's open up the shader graph. So we have this material, okay, and we're gonna go edit. And this material has a lot of other things because obviously the texture is required. So I have multiple things that I'm doing. So I want to make sure that you understand how it all works without having to worry about the other stuff, right? Because you're not going to do the same thing I'm doing. So I'm just going to give you an overview and I'm going to unplug it so you understand what is actually working. A lot of this has to do with the transparency. Remember when we talked about the transparency stuff? Let's do that first. So we have this lit URP shader. And if you don't know how to do this, you just right click and you create a shader in the inspector. So if you go in here, you say create shader, create URP shader. Let's see where it is. You'll probably find that before material rendering. It's a shader graph. And here URP, or if you're doing built-in, and then lit or unlit, you can change this after. So you select this and it'll create a new shader, and then you apply that shader to the material. And so that's what we did to look it up. In here, you'll see that it says lit, unlit. There's certain things in here like blend mode in here, blending mode, transparent or opaque. So you could do opaque, or in here you have alpha clipping. And this alpha clipping is what gives you, instead of doing the smooth transparent, it'll give you a cutoff. See, so you see the difference, how now it's actually all the way through. So you don't see it. So this gives you like that illusion, perfect illusion that it's coming through, right? And then if you wanted to do double-sided, you could as well. I didn't do that because it was very distracting when the player does it on screen. So there's the alpha cutoff. Okay, so that is something that you can tweak with, you can play around with. If you want a smooth fall off with the transparency, you can do that as well. A lot of the things in here are meant to be for the shader. So let's go into the actual mechanics and then I'll cut it off. So we have this stuff right here is not needed. All this stuff is fluff. This is what, like, most of the stuff that cuts it off. If we follow here, alpha, that is essentially what we need. The other thing that was happening is emission. So I have emission because what will happen is you'll go crazy trying to turn it off, right? But emission is not the base layer. It's like an additive thing. And it depends on how you set it up with emission. But for the most part, what you'll see is that if I don't have this, let me see if I can turn it off now. Because I had other stuff happening with the emission without breaking it too much. I'll put that there. We skip this. So it's bypassing the alpha. Let's look at it. Did I save it? Okay. Sometimes with the transparency and this, the emission wasn't working. But if you have the alpha cutoff, you don't have to worry about that because it'll cut everything off. So that's the difference between like the alpha cutoff. I could also, let me go back and change I'm changing here, the alpha cutoff. And you see in here, you saw the monster appear. So these are things that I want to bring up to your attention because there are specific settings, right? And the little things matter. So you see how this is like still kind of transparent in comparison. You see this is more like solid as you go through. The problem is that this emission is still going on. So if you're not doing the alpha cutoff, you're going to get emission to come through. If I go back to, let's do this with the transparency. Now you'll see this effect. See, so that's the emission. So if you want to take this out, you have to deal with the other layers that are in here. And that's why it's doing a lot of these things. So if we remove the alpha clipping, so now we have the settings are alpha clipping, actually adding it, sorry. And then we took that out, so we don't need to deal with it. Let me move that. So now we have the dragon how we want it. Okay. Again, these are just tips. I want to make sure you understand these settings going back and forth, because oftentimes you will come here, you will skip forward, or you will go exactly what you want, how to do the transform, the rotation, and then you're like, it doesn't work. It doesn't work. I've heard that in a lot of tutorials because there's little settings that matter. And so I just wanted you to understand those so you don't feel overwhelmed when things don't go the way you thought they were. You got to understand that there's other settings in the shader that are not right there. Now that you understand kind of like the overall, that all this is doing is adding the color to the cutoff. So the cutoff is essentially this. These are part of me saturating and messing up with the cutoff, like if I want to disable. So one of the things that I realized is, let's say you start the spawn. You have the spell that opens it up. Let's say you do like a Doctor Strange spell and people are walking through, right? And then they're cutting off. That cutoff will stay there, and it's a plane. It's a plane that goes infinitely. And it's a specific rotation. So I haven't like dialed it in to actually cut off certain distance. So if the dragon or anybody comes back the other way, the cutoff is still there. So what I'm doing is in here, I'm saying, hey, like if this thing is disabled, then we're just gonna ignore everything and just set it to 1. So essentially what we're doing is, after a while, when the dragon's all the way out, I turn off the cutoff so that the dragon can go everywhere without cutting off. Again, so this is a trick, and it's not 100% done. It just gets the point across. So right now you have a huge infinite plane and a direction, and the dragon is going to come out there. So if you wanted to make a huge portal that spawns a lot of things in the same cutoff, you could do that, and this would take care of that. It would do all that, or even bigger. It doesn't matter how big or how far it is. It will create the cutoff for, it's an infinite plane facing a specific direction. Okay, that is the cutoff. And I can go in another video, and I just didn't care enough to look up, okay, how do I do it over a radius instead of a whole plane? I can do another video if people are wanting to do that. But for this scenario, all it is right here. Like there's not, like this is it. The rest is just kind of like to multiply, saturate, and kind of mess with the value so that it's like finite. But at the end of the day, this is all you need right here for your cutoff. The cutoff position and the cutoff direction are those parameters that we influence in the script. And so what we do is we have a position node. This position is set to world. Remember, if you set it to local or like the view or object, the space is within the local. But because it's world, remember, because I have the world position and rotation of where it is. I don't have any references to how it spawned or whatever. Sometimes local in scenarios where you have like parenting, for some reason you would want to do that. But for this, I set up the world position node. I subtract the cutoff position. And that gives me, I mean, these colors don't matter. They're just vectors represented by the color wheel. But the main thing is that you have cutoff position. Again, it's linear algebra with shader. So you're doing 1 minus, so like the cutoff position minus. So this gives you what you need. And then the dot product of the direction is what gives me, it's adjusting the plane. So all these is math within the shader. And you can get the math from ChatGPT. You can say, hey, I need a shader that creates a cutoff position based on the direction, but I need to do it in world space. And then it might tell you like how to draw the shader like code. And you can say, I'm using shader graph. How would I translate these values to shader graph nodes? And it would tell you which nodes to put and how to use them. Sometimes it's not completely accurate, so you have to mess around with it, but this works. Again, like I showed you, this worked. And then I finesse it with a multiply to kind of, to decide, okay, like how stretch. If you wanted to do like bigger fall off, you could do this to 20, and you see how it the fall off, it changes the fall off. Okay, and then you do a 1 minus if you want to reverse that to get the opposite effect. So if some things are not working, or you're like, hey, it's doing the opposite of what I want, because it's a cutoff, right? So how does it know which side to show? Well, if you can either change the direction, or also you can do a 1 minus and it will revert the operation if you want it as well. But most of this stuff, the magic is here, and it's linear algebra. And it might sound easier, or you can ask ChatGPT. That's why sometimes you might not need a degree anymore to do these things, but you do need to understand that they exist. The only reason I was able to do this is because I already knew a lot of shader graph from Unreal, and it works the same way. And so I knew this was possible. And I wanted to share this because it's a cool feature that you might use in multiple scenarios with effects and shaders. Like, what if you get hit? Like, for example, if you have a shield and it hits and it does like a ripple effect, or an earthquake that moves the earth, or whatever you want to do with the effect. And you're like, I need a position in space, and then display that. This is how you do it. You can set specific world coordinates and create shaders that react to that. For example, like how far a camera is from a player, and so you can give it the camera position and create different effects that way. So the shader is the same, but it has a feature where it detects via script, detects the camera if there's a camera, and then it can just put the position in here and change the shader how you want. So this opens up a bunch of new things that you can do with your shader that are based on your game and mechanics around the world. So they're not static, they're changing based on what you do. So that's why I wanted to share, because should open up a lot of possibilities for you in what you can do with your games. And in my scenario, I just spawned a dragon, which you might say, well, that's not a lot, but you can do a ton of other features with this. If you have any questions, let me know in the comments below. We can talk about it some more. But see you in the next video.